Okay, the theme here is that the triangle sum theorem says that the angles on the inside, the interior angles of a triangle, add up to 180 degrees. So in order to find the values in x, y, and z, what you should do is look for the inside of a triangle adding up to 180, or look for linear pairs. Linear pairs are supplementary angles that make a line. So for the blue triangle, what I would do is I would do 180 minus 65 minus 39, and you get 76 degrees. So x right here is 76 degrees. Write it in your diagram. So x and y add up to 180. So 180 minus 76 is going to get you y. So 180 minus 76 is 104 degrees. So y is equal to 140 degrees. 104. Then this red triangle is going to be 180 minus 21 minus 104 to get z. So 180 minus 21 minus 104 is 55 degrees. So z is 55 degrees. To classify triangles, you can name them by their angle measures and their side lengths. So equiangular means that all angles are equal. An acute triangle means all three angles are less than 90. So all less than 90 degrees. A right triangle has one right angle. You can't have two right angles because that would be over 180 degrees. An obtuse triangle has one obtuse angle right there. You can't have two obtuse angles in a triangle because that would be over 180 degrees again. Equilateral are all three sides are equal. Isosceles is when you have two sides equal and one other side different. And scalene is when you have three sides all different. So because it says 1 tick, 2 ticks, 3 ticks, it means all these sides are different. Okay, for an example, draw and mark it. So put your angle marks, put your hash marks to fit each description, if possible. It might not be possible. So an acute scalene triangle means that all angles are less than 90 and all side lengths are different. So all angles less than 90. Oh, we'll just pretend that's 89 because it's pretty close. And then all side lengths different. 1, 2, 3. My markings show that they're all different. I could do one arc, 2 arcs, 3 arcs to show that those angles are all different. Isosceles right means that we have to have a right angle. So I'm going to draw a right angle. And two sides are equal. The two sides are equal have to be the sides that are with the right angle, adjacent to them. This would be the hypotenuse. It's a right triangle. An obtuse equiangular means that you have one angle that's greater than 90, but then all angles are different, so that's impossible. Exterior angles of a polygon would be if you have a triangle and you extend each of these lines. These would all be exterior angles right here. Exterior angle, exterior angle, exterior angle. You could also draw the same shape and extend the angles out differently. See how I kind of made the lines go different? It's the same triangle, but I made the lines go different. And these would be the exterior angles. The exterior angles of a polygon add up to 180 or 360 degrees no matter what. No matter if the polygon is a pentagon, the angles still add up to 360. No matter if the polygon is a hexagon or a quadrilateral. remote interior angles are if you have this angle right here, triangle, this exterior angle. The interior angles are the ones that are non-adjacent to that angle. So these two blue ones would be the remote interior angles. If I'm talking about this triangle over here, the remote would be inside, or remote non-adjacent interior angles would be these two angles right here. So it's basically not this angle right here, because this would be supplementary. It's the other two angles. It's not this angle, it's the other two angles. So the triangle exterior angles theorem says the measure of each angle of a triangle equals the sum of the measures of its two remote interior angles. It's kind of a lot of wording, but here's what it looks like in a picture. So if you have this exterior angle, this angle is equal to this angle plus this angle. So angle 3 is equal to the measure of angle 1 plus the measure of angle 2. If I had an exterior angle over here, let's say I made one over here, this is exterior, we'll call this 3, then 1 and 2 would be right here. So the measure of angle 3 equals the measure of angle 2 plus the measure of angle 1. And really, when I do this, I don't really even think about that theorem. I just think that, okay, this one right here has to be 180 minus the measure of angle 1 minus the measure of angle 2. And then I just do 180 minus that to get angle 3. So you don't even have to think about using that theorem, but it's a lot of times it's a shortcut. Okay, classify each triangle, so name it by the angle and the side length. So 2 names. So there's the angle right here. It looks like this is an obtuse angle, and it's tough to see if because there's no marks, I'm assuming that all 3 of these sides are different. So because it has an obtuse angle, it's called an obtuse, and all 3 sides are different, scalene triangle. This one, name it by the angle, is a right. And because these 2 sides are equal, it's a isosceles. And these show all 3 sides are equal. So this is an equilateral triangle. By the way, if a triangle is equilateral, then the triangle is equiangular. That doesn't need an L right there. Equiangular, it's hard to say. And in a triangle, it's actually a biconditional. In a triangle, if it's equiangular, then it's equilateral as well. So I can just say equilateral. And then this one looks like, and it has obtuse angle again, so we're going to call that obtuse. And then it's isosceles, because 2 sides are equal. In this part, we're going to find the measure of each angle. So x is an exterior angle, and these 2 are remote interior angles. So x equals 65 plus 60. So x equals 125 degrees. Okay, and then second one, P is exterior, and these 2 are the remote interior. So P equals 90 plus 46. So P equals 136 degrees. Third one looks a little bit tougher. Well, I got this. I can't do anything with this triangle yet because I have 2 missing angle measures. But I can figure out what B is. So B is 180 minus 72 minus 86. So B is 22 degrees. And by the vertical angle theorem, A is 22 degrees. See, these two are vertical angles. So now C is going to be 180 minus 22 minus 70. So 180 minus 22 minus 70 is 88 degrees. Okay, and then the third one, or the fourth one, is I got A, B, C, D all up here. I don't have enough in this triangle. I only have two angles, or one angle, but I do know that these two form a linear pair. They add up to 180 and make a line. So this is 60 degrees. Now I can figure out what A is. A is equal to 180 minus 32 minus 60. So 180 minus 32 minus 60 is 88 degrees. So A is equal to 88 degrees. By the vertical angle theorem, D is equal to 88 degrees. And B forms a linear pair. So B is 180 minus 88. So B is 92 degrees. And C is vertical with B, so C is 92 degrees. And the last one, look for the triangle that has two angles in it already. So I'm using this one. You could also do that B is the yellow ones added up. So actually I'm going to do that. So 44 plus 53 is 97. So B is 97 degrees. Mark it in your diagram. C forms a linear pair. So 180 minus 97 is 83 degrees. And now this this blue triangle now has two angles, so I can find A. A is going to be 180 minus 97 degrees minus 28 degrees for these three. So A is equal to 180 minus 97 minus 28 is 55 degrees.